Hi guys, today we compress this DAG tree with parameterized grammar. So as a first step we write the grammar representation of this tree, and so we begin with a start node, which is a root node. Then we write the first child, that is n. Then we write the first child of n, that is f. First child of f, that is t. Then next child of f, that is l. Then again write first child of l, that is t, and next child of l, that is minus. Then we close this bracket here. Okay, then we go to the next child of n, that is n itself. So this is the next child of n, and again we do the same. And so first child of n is f, first child of f is t, and next child is l. First child of l is t, next child is p. First child of p is t, next child is minus. Then we close this bracket and close this bracket. Then the next child of n is minus. Then we close this bracket. Okay, then finally we come to r. So we first close this bracket, which is this the first child and second child, so we close this n here. Then we write the next child of r, that is minus. Then we close r here. Okay, now if we see this grammar, then there is something common. The common thing is this part. So we can write this as a function of minus, and similarly this part is also common, and this can be the function of bt minus 1. So let's suppose this function of fn, fl, so let's say f of some arbitrary x will give you the whole expression, that is f of t l with t and some arbitrary expression here. Then we close this bracket here. So if you suppose if you put this formula in above expression, then it becomes start r. Now see here, and this is the function we suppose, and this is the f of l, and where x is minus, so we write fl with minus. Then comes this comma. Then again we go to next method, that is n. Then this is the function, this is the end of the function, and this thing is the x, so we write fn of x, that is b t comma minus, and we close the fn. Then we write rest this. Then this bracket is closed here. Then we write minus, and this is the closing bracket for this, this is the closing bracket for this, and these are the two childs of n. Okay, now if you see, then there is again the common thing, that is the whole NFL. This is, sorry, this is not fn, this is fl. This NFL, and here is also NFL. So if you see, then we can again make one method. So if this is an x, then it would be a function NFL such that this is x and this whole thing is y. So let's write this function as NFL. NFL of x and y will give you n of FL of x and y. So if you suppose this method up, then it will be start L, the whole thing is NFL, so we write NFL. Then here x is minus, so we write minus. Then this is the whole thing is the y, but y again can be compressed, so we again apply this logic to the y. So y is again NFL, and in this NFL the x is this is x, as we know previously this was the x here. So NFL where x is bt minus, and this is the y for this NFL, so we write y here and we close this NFL bracket and we close this NFL here. Then we close this, so we write other things same, and this is the final expression. So we have the two rules, that is this A and B rules, and the final expression. And in our final expression, what we do is we can again avoid this rule. So what we do is we put FL here and it can be further decomposed, and finally while saving we only save this and the rule number B.